Hello, dear students. Today we can study a simple program using 8085 assembly language. The addition of two 8-bit numbers. The result can be either 8-bit or 16-bit. So generally we are using the result as 16-bit. If the addition results in a carry, the result contains 16 bits, otherwise it contains only 8 bits, which means that we need only one memory location for storing the result if the result is without carry, and we need two memory location if the result is with carry. So we are using two memory location itself. The only difference is that if the result is with carry, the second memory location is 1. Otherwise, if the result is without carry, the second memory location will be 0. And for addition operation, we can use the instruction add, add, and it is followed by any of the register name or EM. And in our problem, the input data is given in memory location. We can use the instruction add m, and for add m to be used, one of the data to be kept in the accumulator and the next in the memory location itself, and the result will be stored in the accumulator. After the addition, the result will be there in the accumulator, and since we have to store the result in the memory location, we have to use the storing instructions to store the accumulator content in the memory location. And first we can go through the flow chart. Start. And in our program we have already said that if there is a carry, we have to store 1 in the most significant byte of the result. Otherwise, the most significant byte of the result is 0. And since there is no provision for storing the carry as such, we are setting apart a register for storing the carry. It is clear register C for storing the carry. And since the input data and the result are in consecutive memory location, we have to initialize the memory pointer at first, which points to the first data, then load accumulator with the memory contents. Since one of the data is to be kept in the accumulator for addition operation, then increment the memory pointer to the second data. Now we can add memory with accumulator. After addition, we have to check for the carry flag. If carry flag is 1, increment register C. Otherwise, we have to skip this instruction, that is register C will be 0 itself. Then after that, increment the memory pointer to store the accumulator to that memory location. Then again increment the memory pointer to store register C, which is actually the carry contents, then stop. Then we can map this flowchart into instruction. Clear register C, which can be done using the instruction MVIC, 00. Initialize the memory pointer can be done using the instruction LXIH 2101. 2101 contains the first data. Then it is to be moved to the accumulator using the instruction move A, M. Then increment the memory pointer. It can be done using the instruction INXH. Then addition can be performed using the instruction add m, and after add m, the result will be there in the accumulator itself. Add m plus a, and the result will be in the accumulator. Then if there is a carry, we have to increment the register C. Otherwise, this step is to be skipped and to increment the HL pair. And for that, we have to use a jump instruction. Jump on, no carry, skip. It is if carry is 0, this instruction is skipped and the next instruction INX-H is executed. And if carry is 1, after executing this INRC, it will execute the instruction INX-H. After that, the accumulator content can be moved to the memory location for storing the result. Then again the memory pointer is incremented to store the contents of register C, which actually contains the carry. Then program stops. Hope you understood the program. Thank you, dear students.